Okay, then good morning, very good morning, all of you. Today we have our day 4 of this webinar series on artificial intelligence data science. And the motive, as I've explained earlier to our participants, is to ignite the thinking, the aspirants who are working in this field or those who are graduates and existing companies to understand the usage of AI and data science to solve various issues, to solve various problems, to change our perspective. And in this line, today we have Mr. Aakash Ahuja, founder and CEO of ITMTB Technologies Private Limited. And we are great privileged to have you, sir, on board. His topic of the talk would be industries using AI to solve customer problems and also touching upon the related career opportunities. He is the founder and CEO of ITMTV Technologies. He is an NIT Raipur graduate in electrical engineering, and previous to establishing his own firm in 2019, he has worked with various giants like HSBC Global Technology Center, Accenture, and Teradata India in various technical and leadership roles. We are privileged to have you, sir. Over to you. We can start the session.
Saketji, trust me, the privilege is all mine. So before I start, a very warm welcome to all the attendees over here. It's always a wonderful experience to be interacting with uh, people who bring up new ideas, and you always get to learn a lot from these sessions. Again, thanking C-DAC Patna for giving me this opportunity to be over here. Okay, so let's start. Now, before we start, just let me quickly introduce me and my relation to AI. Now, Saketji kindly introduced me in terms of my career experience. Now, while working with all these companies, I got a lot of opportunities to see a lot of different business domains, a lot of different challenges that we're trying to solve. Some were in B2B segments, some were in B2C segments. And over my past 15 years of corporate experience, I saw how they evolved from a traditional siloed industry to someone who was to industries who were more open to adopting more of new technologies of artificial intelligence, cloud, and so on and so forth. And that eventually propelled me to start something on my own in the financial technology domain. Now, we are more popularly known for Prosperator, which is the platform that we have created for people who do not know how to trade in stock markets. We have simply solved this problem by bringing the experts on the platform who are SEBI certified investment advisors and research analysts. The platform verifies them, we verify them, and that is how we solve the skill problem. Now, if you go to the website, you'll not find it any different than a plain vanilla e-commerce website. But the underlying engine is an extremely powerful artificially intelligent engine. There are components which are using a lot of reinforcement learning, deep learning, neural networks, machine learning, you name it. And the engine are using different technologies to solve all these different problems so that the end result that we can deliver to the customer is a very unified, very reliable trading experience. So this is my experience. This is my direct experience with AI. Now, without much further ado, let's move on to the agenda. Now, I wanted to take this opportunity to talk about how some industries are using AI. And as of now, the use cases are not very unknown. Everyone knows how Google uses it. Everyone knows how Tesla uses it. Everyone knows how Facebook uses it. Um, but I wanted to go beyond these things. I wanted to go beyond these, named use cases, and I just thought it would be a very good opportunity to talk about them, because with that, I wanted to figure out or bring to forth a very important problem that we are seeing nowadays in terms of the level of competency that we are finding out there. So before we talk about those industries, let's quickly talk about uh, what we would be covering over here. So I would quickly take a few minutes to start with talking about the challenges that industries face with AI adoption. Then some of the areas that I have chosen to talk about AI usage are UK's COVID response, mining, telecom, aviation, and also associated other industries like oil and gas and manufacturing. Then we talk about the opportunities and how to get them. And at the end of it, I would like to take a few more minutes to talk about what I think is the next frontier of analytics. So let's quickly start with the primary challenges that I find with AI adoption. Now, out of my discussion with a lot of these industries and business leaders, I always come up with two broad problems why they are not able to adopt. One being that many businesses are still trying to figure out how AI can be used to improve their bottom line. Now, it might sound a very mundane statement to make, to some extent unbelievable as well, but trust me, as of now, uh, I think 2 years ago, Accenture conducted a survey with a lot of Fortune 500 companies, and they wanted to figure out if the CXOs have a clear visibility of how AI can improve their business. Only 44% had a very clear picture of how AI could improve that. 56%, which is a staggering number for Fortune 500 companies, they were still trying to figure that out. And it's a very genuine problem because it's not easy. Everyone can learn technology. Where people lack is the ability to apply that technology. Where people lack is the ability to spot those problems where those technologies could help. The other problem that we have been seeing, and this is the problem that I've been seeing out of our own experiences, we have been hiring aggressively throughout the COVID pandemic. I've been talking to a lot of people who have been hiring. The problem that we find is that you will find a lot of people with certificates, you will find very few people with real skills. And that is where I believe that the kind of interaction or the kind of exposure that organizations like C-DAC provides to students is very, very vital over here. I've been involved with C-DAC in various capacities over the past 2 years or so, and I believe that the kind of depth that they try to provide individuals actually prepares individuals to think beyond the technical implementation of things. And that is what is required. If you can solve that problem, the first problem will start to solve itself. I have a feeling that both these are very, very tightly coupled. Okay, anyways, moving on. Now let's talk about the first and the most interesting use case. And I'm pretty certain it is the most talked use case. The associated topic would be one of the most talked topics in given today's time. Now, what you see on the left-hand side of my screen are the targets that UK wanted to achieve for its COVID vaccination. They had absolutely clear picture of who they had to vaccinate, how they had to vaccinate, in what order they had to vaccinate. There were just a couple of problems. And mind you, UK is a country whose area is lesser than the area of Uttar Pradesh in India. Now, there were some challenges. The most important challenge was how to get the vaccine in the right hand at the right time. It's a small country, all right, agreed. But you don't have all the people living in a very small geographical area. You have people spread across cities, you have people spread across towns, you have people spread across villages, and some of them do not have a direct access to NHS or the National Health Service over there. The other problem was that vaccines expire. And most importantly, you do not know, nobody knew how much vaccine will be available at what point of time. And top it up with the associated logistics. And if that was not enough, the biggest problem was to handle the inventory of the associated equipment. I mean, imagine trying to vaccinate people outside of an NHS center in a village. So someone has to go, some doctors have to go, they have to set up a camp over there. They have to start vaccinating people over there. But here's the challenge. COVID vaccinations require on an average 400 plus different types of equipments. You need syringes, you need swabs, you need refrigerators, you need cooling equipment, you need storing equipment, you name it, and you need it. And this inventory expires. Nobody had that inventory built up. So you cannot just transport that inventory. You cannot just calculate the required inventory, transport it then and there at the beginning, and just focus on vaccinating. No, that was never going to happen. Now, this challenge was tackled and is still being tackled. The vaccination programs are still ongoing, and UK's vaccination is still behind their targets, to be honest, but they have started to accelerate. Now, this challenge was tackled by two ways. First, combining the logistical precision that something like a military organization could bring in, and topping them up with just the right amount of cutting edge technology. They brought in Palantir. Now, I'm not sure if you've heard Palantir or not, but Palantir is headed by a couple of most of the people who formed the PayPal mafia. If you've heard of that, you have Reid Hoffman from LinkedIn, You have that gentleman who funded Facebook. He also is a chess grandmaster of US. I'm forgetting his name. Very smart guy. And they are famous for solving some of the most dominating problems in industry, in government, on the crime scene. You name it, and they are over there. So the UK government, the NHS, they involved Palantir, and Palantir developed a customized solution which was intelligent enough to have a look at all the wide varying aspects of this thing. It looked at the staff databases. It had a very clear visibility of what kind of training levels were available for those staff databases. What was the training level given to a particular person? What was the training level planned for a particular person? They had a complete look at the customer databases, the patient databases. They integrated the warehousing inventories, the logistical capabilities, the routing challenges, the information associated with routing, and combining all these disparate databases, they came up with a model which made the vaccine delivery very, very efficient. Now, if any of you were to go to the internet right now and search for the UK's vaccination rate, you will see that the rate was not very impressive in the beginning. In fact, for such a developed country, it was a very, very bad rate. A country like Israel, which had very limited access to vaccines, was doing far better than UK. But after a point of time, the curve starts to go up. And that was the point of time when this solution that I'm talking about on my screen was implemented. And all of this was pure, sheer artificial intelligence. Now, words might not do justice to the scale of this solution, but here's the thing. We are talking about 8, 9 different types of databases. And they were created by different agencies. So they had data quality issues, they had data integration issues, they had all sorts of challenges. To come up with a working solution that handles such a big problem is no mean feat. Now, that brings us to my next favorite thing. Now, if I talk about, I often like to ask this question to people. I ask them, which industry do you think is impacting you mostly nowadays? And mining never comes up. Trust me, it never comes up. 8, 9, 10 times I've asked this question to people. Not once anyone has mentioned mining. And I'm pretty certain all of you would be thinking, mining? No, I don't think mining impacts my life. But here is a fact. Every time you pick up your phone, the cobalt is mined. Every time you do anything with any gadget, the ingredients are mined. The copper wires running inside your equipments are mined. Mining is an industry which actually touches our lives far more than we actually realize or we are actually willing to give a credit to. Now, imagine mining industry for a moment and try and imagine with all the movies you must have seen or if you have any direct experience about it. For decades, mining has been an industry which was totally dependent on human efforts. You had people making judgment about whether this wall is strong enough to or not, whether we should be drilling 2 more inches or not, whether we should be going 30 degrees left or we should be going 15 degrees right. Everything was human. On top of that, imagine working 500 meters under the ground. You don't have light, you don't have oxygen, you have all the carbon particles, granules going on the fine granules in the air, impacting your health and impacting your decision making. Now, if you're a miner, how much can you be trusted to take the right decisions? One wrong decision in that environment, and you jeopardize hundreds of other lives. But this has been going on. So when mining started to adopt artificial intelligence, trust me, I was the happiest. And look at the areas. Because it's a dangerous environment, people realize that you cannot solely rely on human judgment. Situations will evolve. Nobody can foresee what happens inside a mine. People had to be trained. But they went one step ahead and decided that now we are not just going to use simulators. Simulators have been used in training for a long, long time. Aviation and space travel have been using simulators for a long, long time. Mining decided to use simulator-based training, but not just that. Along with simulator-based training, they used a lot of wearable sensors applied on the miners who were being trained. So now they were using a lot of IoT and a lot of healthcare combined to detect if a worker was at a point where he could make a wrong decision, if his health was at the point where he might be feeling compromised or might be feeling jeopardized. And that way, they were able to bring out a lot of improvements in trainings, reduction of accidents, and so on and so forth in this very important area. The other area that we always associate mining with is carbon footprint. Mining, oil and gas, energy, any kind of thing directly or indirectly related to energy has a huge carbon footprint. Well, huge might be an overstatement because nowadays construction produces the same amount of carbon as energy does. It's about roughly about, I think if I remember correctly, construction is about 23% of carbon emissions. Energy is about 26, quite close. The numbers were starkly different 10 years ago. But that's still a problem. But this industry is taking giant leaps in solving that problem. Quite simple. They are using a lot of machine learning to figure out their energy peaks, energy consumption peaks. They are using a lot of machine learning to handle those energy peaks. So, for example, they have automated ventilation systems which could adjust adjust optimally according to the necessity right now. That way, they are combining a lot of natural ventilation, reducing their energy footprint, and also reducing the overall carbon footprint. Now, surprisingly, mining was late to the scene to adopt this. Companies like Facebook and Google have been using a lot of these technologies to reduce their carbon footprint. 5 years ago, Facebook was in the news for their was it Swedish or was it Norwegian? I don't remember right now, but somewhere on the Eastern Hemisphere, Northern Hemisphere. Um, their Swedish data centers, when they had to build their data centers, they decided that we are going to build our data centers at a location which has a lot of ice, thereby naturally cooling the servers. Now, all they had to do was to ventilate naturally. They had AI controlled ventilators. They simply ventilated air from the outside inside, and now we don't need any air conditioning. Air conditioning has been the primary source of carbon production in computer industry. Of course, along with indirect operations like mining. Google has done the same thing. And I think 2 years ago, Google managed to achieve carbon neutrality for one of its data centers. Carbon neutrality means the amount of carbon that you produce is the same amount of carbon that you are sequestering from the environment. And to be able to do that, they had to cut down their uses drastically, and they greatly used a lot of AI powered solutions to do that. Third area where mining uses a lot of artificial intelligence nowadays is in object quality, in produce quality. We can call it efficiency if you want. There was a time when you had to look through what was produced to decide whether it was a good grade product or not. A lot of industries still do that. You still have human mind testers, if you may. You still have people taking manual judgment on whether a diamond that has been produced has the right quality or not at the end of the process. Mining was no different. You had to look at the minerals produced, to the texture, to the color, to the stratified layers over there to figure out whether it was good quality or not. But now they are using a lot of image recognition, a lot of artificial intelligence to decide all of that. So mining as a whole is had COVID not happened, mining would have been at the top of my list as an industry which is really being transformed by better adoption of technology. Telecom, something that all of us use. Now, the biggest problem that one faces in a telecom industry is, needless to say, it's infrastructure management and uptime. Telecom networks have a huge physical infrastructure. Anything can go wrong. And if it's critical, then a lot of things can go wrong. Which means preventive maintenance becomes a necessity. You can't wait for something to fail. You have to be able to go and fix it before it fails. And on top of that, you have got customer complaints. If you don't have a happy customer, the customer has a lot of options to go to. And telecom companies have been facing these challenges from a long, long time. But now, recently, with the advent of good technology companies who are coming up with really innovative solutions, they are able to get some amount of grip on that. Now, I'm going to talk about two different companies. I'm not going to name them because I've worked with one of them. I was a part of that project myself. Now, first of them, a European telecommunication company, they simply decided that the best way to figure out where a problem is going to happen is to build a digital twin of our entire physical network. Now, imagine a network which is spread across an entire continent. You have towers, you have routers, you have amplifiers, you have sensors, you have transponders, you name it, and they are over there. They built a complete digital twin of that entire layer on a server. So now they could, and it was not just a map, it was not just a pretty picture. It was a total simulation of how the actual network is working. So if at any point of time, one particular cell tower was using 85% of its capacity, at the same time, their digital twin would show that it is 85% loaded. Um, and with this, the greatest amount of benefit that they reaped was that they were now, for the first time in their history, in a situation to simulate what happens when something changes in the network. They could simply simulate an overloaded situation on one of their towers and see how it impacts the rest of the network. Networking has always been one of the most complicated challenges for technology to solve. And by simply having a digital twin of that, they were able to not just better predict the problems, they were able to fix the problems before they could actually impact the customer. They were able to manage their people and resources better. They were better able to handle customer complaints better, and so on and so forth. This other telecom company, and I personally worked with this company, another telecom company from Europe, well headquartered in Europe but has global operations. They realized that were having a lot of challenges in their customer care department. People were calling, they were not happy with the transactions, and so on and so forth. So they decided to use AI. Their AI system is now fully commissioned. And as of today, that company has the capability to predict which user is going to call because of a problem. Let that sink in. I'm repeating that again. Today, that company has the capability to predict which user is going to call because of the problem he or she is facing, and they proactively address that. Imagine your company calling you beforehand saying, excuse me, sir, or excuse me, ma'am, and we are from this company, and we would like to inform you that in the next hour, you might see some disruptions in your phone. But don't worry, we are working on it. If that happens to me, I would never leave the telecom company, trust me. And I'm certain none of you will. So simple usage, simple leveraging and mining of their existing data allowed them to do this. And the result was 20% plus year on year reduction in customer complaints. And if you're not aware of the importance of this statistic, understand this. If you reduce customer complaints, you reduce the cost that is being spent to handle those customer complaints. And if you're a global company, that's a huge cost, especially in a domain which is very much fighting for margins. So that's a huge impact to bottom line. Aviation. Airbus. It's an open use case. You can read about it on the internet. Airbus started to use AI to understand how often the parts on a plane fail. Statistically speaking, airlines are the safest mode of travel. Very few people know that while you're in a plane in the middle of flight, cruising at 30,000 feet, parts in an airplane do fail. We just don't realize that. Uh, and airlines and airplanes are built to handle those failures, even if they are in mid-flight. Very few people know that planes are designed in such a way that even if one engine fell off to the ground, the plane would still be able to land safely. Although that's a story that's unrelated. So let's come back to this. Whereas it is good to have safety in a flying plane, whereas it's always desirable to land safely on the ground. If parts fail, they are a cost, and not always you can control them. So it's important to understand the pattern in part failures. Airbus decided to use AI to handle this. They tackled the most burning problem. They said, how often my parts fail? Forget about which part is failing. Just tell me how often they fail. If this part fails, what happens to the cost and the associated rework? And most importantly, what are the consequences of its failure? I mean, what should I prioritize? What should I train my pilots, my captains, and my flight assistants to prioritize if they're in mid-flight if something fails? And they are able to do this not just with AI, but they have used a lot of AR and VR simulations to understand these. And this is a lifesaver. It truly is a lifesaver given all the potential and possible consequences out there. Now, surprisingly enough, the same technology is used in oil and gas industry as well. You are not going to send your divers to 300 feet under the sea to figure out whether you're going to find natural gas over there or not. You're not going to send your divers or a submarine every time under turbulent seas in Arabian Sea to figure out if you change the size of your well, how much it is going to change your output. That's not always possible, that's not always safe, and that's not always cost effective. So nowadays, they are starting to use a lot of AR and VR, augmented reality and virtual reality, to predict all those things. They look at a computer screen, they turn a few knobs, and they are able to see the cost of the benefits and the challenges of doing that. Manufacturing does the same thing, but this time they use it to remotely guide workers to fix the machines. Imagine you are GE, General Electric. You have sold a big machine which is deployed in Assam, in one of the oil fields of Oil India Limited. Now that machine is malfunctioning. Now that machine has to be shut down unless someone from GE comes in, observes it, figure out what went wrong, goes back, comes back with the part, fixes it, checks it. Huge loss of output. So what they do? Now they have these AR and VR setups wherein there would be this guy in GE's office in London or San Francisco or wherever. There would be that guy in that oil field. Both of them would be wearing their AR and VR glasses, and this expert from San Francisco would be instructing him, saying, you see that red knob, just switch it 10 degrees, turn it 10 degrees. This guy does that, and they are able to see the same thing on a virtual screen. This capability, although it's only available to people with the right amount of budgets, has greatly improved the downtimes of these big operations. And now that I'm talking about it, this example just struck me. I forgot to put it on this slide. Do you know how cars are designed? Before you get a new model, the cars were designed manually. You had a life-size clay model. There were people who were experts in designing clay models of life-size cars. And they were so perfect at their art that their clay model would look exactly like a new car. Previously, the process to bring a new model to market took 5 to 7 years on an average, depending on how efficient the company was. Now they use AR and VR. The time to produce a new car, and when I say a new car, I mean a new model altogether. The time to produce a new model, right from drawing board until your dealer's showroom, has now been cut down by anywhere between 40 to 60%. You design a car in AR and VR, your management can come in, they could actually open those virtual doors, see how the car looks from the inside. They can even see the spacing between a nut and a bolt and whether it matches their quality parameters or not. All of that in AR and VR. It has not just led to a reduction in costs, it has also led to an increase in safety, customer safety, and it has also, as I said, it has reduced the time to market for these wonderful cars that a lot of people can now use. Now, that's a lot about what industries are doing. It's an endless list. Trust me, it's an endless list. I can go on for days and days, and still the list would still be wrong. Still remain. The question is, what kind of new career frontiers it brings to us. Now, I have selected two for an example. Now, these are examples because I want to highlight an important point. These examples are even the Indian government is nowadays laying a great stress on adopting AI for its workforce. Another brilliant example is SEBI, Securities and Exchange Board of India, is looking for IT analysts for specific doing machine learning and all that stuff. Now we are talking about a whole government of a large country as India laying emphasis on this. Government has a say and a control on everything that goes in the economy. Now, if the government is looking to emphasize AI, imagine that every industry over here is going to use AI shortly from now. Which means that no matter what your area of interest is, you will find applications over there. You will find AI being used over there. But that should bring you to this important question is what is it that it takes to be there? And this brings me back to the first slide, problems of adoption. Don't just look to remember all these things. Don't just look to mug up all the formulas and all the functions and all the libraries. No, that is the most common mistake. I've seen people who are presenting me these wonderful plots and visualizations, and I ask them, what does the plot mean? And they have no answer. No right answer, of course. So you really have to understand the foundations, the fundamentals as a student of whatever you're doing. You have to lay a great stress on statistical foundations. A lot of people are always fancying things like deep neural networks and machine learning and this and that. Almost everyone ignores the statistical foundations. C-DAC has a course, a dedicated course, a dedicated module for data analytics that just focuses on statistical foundations. And if you can understand it, you will realize that being good at statistical foundations is much more important than just remembering what those libraries are. It really adds to your produce as a programmer. Of course, you need to know programming languages. Of course, you need to know intelligence models. And most importantly, you need to know domain knowledge. We have talked about these domains. We have talked about mining. We have talked about healthcare. We have talked about telecom. Now, if I asked you what happens in mining, tell me 3 problems in mining, hardly anyone would be able to tell me that. In my experience, people who have made lasting solutions, lasting technology solutions, have been the ones who were at the crossroads of technology and domain, who understood the area they were working for, who understood the technology, and those were the ones who were able to integrate them better. So if you want to have a lasting career, you need to have all these things. The most important being a clear understanding of fundamentals, including data analytics and statistical foundations, and a clear understanding of the domain knowledge. If you can do this, no matter what area you work in, no matter what field you work in, you would have a lasting career. And we know that now AI is just beginning to open up in all the possible avenues. One last minute as I talk about the final frontier. Everyone asks me what's next, and I have always one answer: quantum computing and analytics. 5 years from now, 6 years from now, we are going to see the term quantum analytics much more common than we see it today. Quantum computers were a stuff of fantasy 20 years ago. Now they're real. IBM has it, Google has it. If you wanted to use a quantum computer, AWS has a quantum computer. You could rent it for what, $60 an hour, if I remember. Sorry, yeah, something like that, if I remember the rates correctly. Like every technology, it is expensive today, but every technology has become cheaper. We have seen this happening for the past 70 years. It's not going to change. So analytics, artificial intelligence is going to evolve into quantum intelligence very soon in a matter of years. But you will not be able to adapt to that unless you know the technologies of today. So spend some time understanding this. It's a very wonderful field. Spend some time learning the skills from the right people, and then the sky is the limit for you. Okay, that brings me to the end of my discussion. I can take any questions if anyone has them.
Thank you, sir. Thank you very much. It was a great session, and the way you have put up both things, as in what all companies domain, how to that perspective of companies domain can use AI, and plus the career opportunities for the aspirants in this data analytics and AI. That was great, sir. Thank you very much. We have a few questions. I think Parul, you have raised your hand. Perhaps you had a question in between the talk. You could ask now. No, sir. Oh, okay. CVSN Reddy, you have raised your hand. Any other participants who have
Sir,
any? Yeah, please.
sir, Amarjit Sharma. Sir, I was listening the talk entirely, and I just want to ask, sir. You said that application of the knowledge. Many of the people who teach these courses and give the certification, they more focus on the libraries, their usage, and the plotting beautiful graphs and all. But candidate at that point didn't know that this application of these things, because in the name of application, there are dummy projects they do. So, sir, for them, please say something, because you have experience from ground to the various roles. So you have, I think, already have these problems to the your colleagues or the juniors, whoever you work with, sir.
Okay. I think I'm the right person to answer this question. Let me tell you why. I have had a lot of academic stints with C-DAC Acts. I have also taught artificial intelligence for IIT Guwahati and a couple of other NITs. What I can tell you is that yes, you are right that a lot of these certificate providers don't deliver the kind of promised quality, but then you need to find the right place. CDEC is one of the places where you find the right quality. They insist on bringing uh, people with industry experience only. And when you have someone with industry experience, he doesn't teach you from a presentation. He uses a lot of whiteboarding. He'll give you a lot of industry examples. He would have faced a lot of challenges and he would help you understand those challenges. So the sweet and short answer is that yes, the problem is real, but the solution lies in choosing the right partner who can help you learn these things in the right way.
Very nicely put it down, sir. Any other questions,
Yeah,
participants?
I have a question. This is CBS and Reddy speaking.
Yeah, please.
So he is basically talking about quantum computing is the future, which will basically enable more AI and analytics side also. So I just wanted to understand how we can basically apply quantum computing in different AI technologies, particularly in the deep learning side. Because what I basically felt is quantum computing is very useful when you wanted to do the work in the parallel sense, because 1 and 0 will exist at the same time in the quantum computing. But how do we apply this technology really in the deep learning to basically make the things fast? Because
Okay.
presently, if you wanted to do the deep learning, we are using GPUs, TPUs, and all that. Yes, sir. That is my
So that's
question.
a wonderful question. Um, Let me rephrase my statement before I answer your question. Quantum computing is the future for popular adoption. Organizations are already using quantum computing to solve customer problems. And while I tell you what those problems are, your question will be answered indirectly. Let's take two examples. Genetic research. Human genome is not the biggest genome. In fact, human genome is one of the smallest genomes out there. But even if you have to make a medicine for humans, it takes a lifetime of computing resources. It's smaller as compared to everything else out there in the world, but it's still huge. It's still giant. Healthcare organizations are already using quantum computing to do genomic research, to do vaccine research, and quantum computing has accelerated the rate at which they are coming up with new discoveries. Why? Because now they don't have to wait for one simulation to end before they can begin the next simulation. The whole fact that now they can work with quantum states is allowing them to test more and test faster in a smaller amount of time. And let's not miss the fact that they have increased accuracy in doing so. There are other areas which are already using quantum, like for example, financials. Now, I am from a fintech domain, and in my presentation, I haven't talked about a single application of AI in fintech domain. When fintech is a field that is ripe with AI's applications. The problem with fintech is that economics is a very complicated field. You still do not know everything about that can impact a decision. A lot of companies are using quantum or beginning to use quantum to solve economic problems. So the answer to your question is the fact that you could work with multiple states allows you to run more simulations and finish faster and with more accuracy. I hope that helps.
Yes, sir. Thank you.
And that would be also, thank you very much for your time and this expert talk. And we would be meeting, thank you to all participants also. Thank you to Aakash sir. We would be meeting the same time next weekend on 3rd of April. And today's session was by Aakash Ahuja sir. To my 3rd April session would be on adopting AI for business and spotting opportunity in AI by Kunal Shah sir. So looking forward for all of you to join 3rd April 10:45 a.m. Thank you, Aakash sir. Thank you
All
very
right,
much
then
for your
thank you
time.
very much, everyone. All of you have a good day and a nice weekend.